Hi everyone, my name is Lars Hedlund and I'm a sales manager at Novato Solutions. Thank you so much for joining this session. Novato Solutions is based in Stockholm, Sweden, and we are an NI Gold Alliance partner with RF and wireless specialty.
Okay, so let's get started. This session will be about deploying multi-channel COMINT systems based upon NI COTS hardware. The session will walk you through some benefits of networked multi-channel radio systems compared with conventional COMINT radios. We will conclude the session with a live demonstration of a turnkey COMINT monitoring system. The agenda for this session will start with a traditional COMINT scenario, just to set the scene and have an understanding on what we will talk about through this session. After that, we look at the customer challenges and goals, software-defined multi-channel radios, and then finally we have a demonstration of a COMINT system. Starting with the traditional COMINT scenario, we typically have some emitters in the field. It could be troops or boats and other vehicles, tanks, and these typically talk with each other. What we want to do is to listen in on their communication. We are probably placed somewhere else, and we call these sensor sites. On the sensor sites, we have radios connecting to the antennas. The radios are close to the antennas. It's good to understand. Typically, there are one channel per radio, so we listen in on one of the communications by one radio. With this in mind, let's have a look at the challenges and goals. The goal for any COMINT agency is to surveil the RF spectrum and listen to and analyze individual signals of interest. With more complexity on how the emitters behave and the fact that the emitting signals increasing, there are challenges for these agencies to overcome. Here we'll talk about some of these challenges, which are in no case the only ones. Equipment cost increase proportional with the amount of emitters. The more emitters we like to surveil, the more hardware we need to have. Need of more local operators with increased expert knowledge. The more complex signal gets, the more knowledge the operators need to have. Remember that the radios are close to the antennas, so we need to have the operators touch locally. For example, control of antennas and tuning the radios. Last but not least, the challenge of equipment itself and the fact that it's aging, running out of spare parts or replacements. These are three challenges among many, and the following slide will refer to them and explain how we can help the customer overcome these challenges. But before going to the next slide, I'd like to highlight two goals for the customers. Surveillance of virtually unlimited amount of emitters. Imagine we get rid of the bottleneck of the equipment for how many emitters we can surveil. Capital expenses and operational expenses should stay within budgets. Coming back to the COMINT scenario again and looking at it from a more modern perspective, customers can take different paths to overcome the challenges we just talked about. One path will be to look at software-defined radios and preferably build on modular COTS hardware. The reason doing so over customized hardware solutions from different vendors is that costs can be shared with industry applications. In fact, in many segments, industry have also paused aerospace and defense development and innovation for a long time. On the technical side of software-defined radios, configurable signal processing units such as FPGAs enable high throughput and parallel signal processing paths. As an example, using a wideband receiver connected to the antenna, one can monitor wideband RF spectrum using FPGAs to extract thousands of narrowband channels to be further inline processed in comparison with the traditional radios that we had in the scenario before, replacing traditional narrowband radios with multi-channel receivers built on modular hardware. The modular design gives us scalable monitoring capacity. For example, adding one additional FPGA to the configuration can double the amount of drop-down receivers, and so doubling the amount of individual emitters we can listen in on. Another advantage of the modularity is replacement of and repair of already installed units. Compared with the conventional radios, the customer can replace only the intended module over replacing the whole system. Coming back to the challenges and goals, equipment cost doesn't need to follow the amount of emitters we wish to observe. In fact, using wideband tuners and digital signal processing, we can replace thousands of narrowband radios with one multi-channel receiver. We probably also have plenty of channels over for any upcoming events. The modularity and cost-based approach help the challenge with aging and obsolescence. New units can replace old, if not all of the modules, so at least some of them. Let's have a look at the scenario again. Distribution of radios over different sensor sites enable us to understand more about the emitters. Example of this is to do direction finding based upon when the signals arrive to the different locations. Sensor sites can be distributed over large areas, including fixed installations and vehicles. Each of these needs to feed the information back to a collection node for analysis and decision making. Connecting the radios with a network makes the mentioned operations possible. A network radio gives many advantages. For example, remote access for configuration, update, tuning of the radio and antennas. Another advantage is the collection of data from several sites, enabling, for example, time differential, direction finding, and other tasks. For the COMINT agency, the network means that operators, experts, and autonomous software can view and access live data from different locations. Coming back to the challenges again, one way of reducing the operational cost is to use network computers. In this way, the customers can centralize their expertise and avoid distribution of personnel more than necessary. Over the years, we at Novato Solutions have listened to our customer needs and helped them mitigate their challenges and focus on their goals. On the next slide, we will look at our solutions to these challenges. Hugin multi-channel receivers. For a quick introduction, we have two multi-channel receivers developed on NI's platforms. Hugin 2000, which has two tuners and can produce 2048 narrowband channels. Hugin 200, which has four tuners and can extract 512 narrowband channels. For both of these units, we use high-performance RF front ends, having a server and client architecture for real-time control and configuration, and for each individual narrowband channel we can independently configure it with the center frequency, bandwidth, gain, filters, and the output data in terms of either demodulation or IQ data. With this, I'd like to finalize this session with a live demonstration. I recorded this demonstration earlier today in our lab. It will be an easy setup using an antenna on the roof connected to Hugin 200 and controlled by an operator's software from Combitech. To the lab. Hi and welcome to our lab. With me I have a couple of Hugin 200s and also the Hugin 2000. For this demonstration we will look at the Hugin 200 and it's connected with the network and also connected to the antenna on the roof. Come with me. So for this demonstration, we will use the software called Sandra from Combitech. First, we connect to one of the sensor sites. After the connection is established, we can see the receiver groups, receivers, and also all their channels. So here we have Hugin 200 and tuner 2, and all the channels on that tuner. Let's open up the receiver control for Hugin 200, and here we can view the spectrum and the waterfall for the wideband spectrum. The operator can, for example, now take over manual control and then tune in on a specific channel or set specific parameters for that specific channel. We're doing this now in the spectrum display. And as you can see, we tune in on a 97 radio, typically. All right, let's release the manual control and let Sandra do some tasking. With activation of this example, we let Sandra automatically tune channels of the receiver. The advantage of having many channels for each tuner, we can avoid the let's say bottleneck for having several users to the same tuner and so on. We have plenty of channels to do tasking and also manual control from different locations. Finally, let's switch to another tuner at Hugin 200 with a center frequency of 446 PMR band. Let's wait on the transmission on the PMR channel 1. As you can see now in the waterfall, we just got it. So we can go into the recording buffer and zoom in on the detection made by VAD, so voice activity detection. And here we can view the waveform and replay and record the record made. And this concludes my demo for today.
Thank you so much for listening, and please join me in the Q&A session for